Capacitor characteristics. So we have seen kind of in many kind of videos that we have talked about the capacitor characteristics. So capacitor is a kind of or we can say it's a device that stores charge. So if it stores charge, then initially capacitor is discharged, and then if I apply voltage across the capacitor, it will start storing the charge, and one time will happen when it is full, and beyond that it won't allow the current to flow. Okay. Electronics is a science of resistance. So if I apply voltage across 2 points in a circuit, then it will look at the easiest path through which it can flow. Okay, means the current can flow. So if two end has a voltage difference, then it will tend to flow a current from a battery's one end to another end. It will take a path, okay, that has less resistance. So if I see, so it's a kind of inevitable, means it's natural to talk about any device in terms of resistance. So if I have a capacitor and it is connected to a circuit, then initial resistance of the capacitor is zero. If there is no charge, it doesn't offer any resistance. So if I apply voltage across it, then sharp current would kind of flow through it. But once charge getting started, when one charge gets started storing into the capacitor, its resistance is changing. And from 0 to once a kind of current is flowing, okay, one time will come, so resistance will grow, and one time will come when resistance will be infinite. At that point, since it is infinite, so either the circuit voltage, so it has to take another path, or if this is the only path, then current cannot flow. Okay, so that is the science of science in electronics and capacitor. Now, can I miss capacitor characteristics we have seen? Very nice. Means we saw the charging time, and then we saw also that it discharges. Where capacitor can be used, where a variable resistance can be used, rather we can say this. So, can we use capacitor in a circuit? How? Means I can, if I place in a circuit, then it will charge. Okay? If I remove the voltage source, it will discharge. Can we think about charging and discharging in different paths? Capacitor would charge from a path, and capacitor would discharge from another path. Okay, so when capacitor is kind of its resistance is zero, and it is connected to battery would kind of source it, and it would fulfill. And when it is fulfilled and connected through the battery, then it will be kept fulfilled. Okay, but if it gets disconnected from the battery some, then it should be able to discharge from the other path. If I can kind of find this kind of charging and discharging, charging and discharging. Okay, so we can kind of find a way to get oscillator. If capacitor is charging, it is discharging, charging, discharging, charging, discharging. Okay, so it is kind of, it will give a wave, okay, electromagnetic wave, where if it is too quick and where there will be kind of a voltage, voltage, no voltage, voltage, no voltage, voltage is growing, coming to zero, growing, coming to zero, a current is growing, coming to zero, growing, coming to zero. So, can we use capacitor as an oscillator. So we'll see that how we can use a capacitor as an oscillator if we provide different paths for the charging and different path for the discharging. So that will get further discussion on capacitor as an oscillator. So we'll see what we are trying to achieve. Okay, so this is a typical kind of diagram of rain LR. Okay, so we have taken it as an oscillator. Okay, now we'll see that what is the circuit actually. So this is NPN transistor and this is PNP transistor. So being PNP transistor, so this is the direction of the arrow of the, so this is emitter, this is collector and this is base, and similarly arrow sign, this is emitter, collector and this is base. So transistor is nothing but it's a kind of a dual junction diode. Okay, it's not a double diode, but it's a dual junction diode. Okay, so in capacitor, in transistor, this is one junction of the diode, this is another. So it's a kind of a straight diode. It's not like the way it is drawn. So two junction, one junction is base and collector junction, and one junction is base and emitter junction. So if base and emitter junction is in forward bias, in kind of active region, okay, and this is in reverse bias, then this transistor is said to be in active state, on state. Okay, so similar condition here. Okay, so this is P and this is N. So voltage at here is more and here it is less. So this would be forward bias and okay. Okay, and this is N and this is P. So at N the voltage is higher and P voltage is low. So this should be considered in reverse bias. Okay, so this is a typical kind of NPN and PNP circuit. Now from base 330 kilo ohm resistor is connected to 3 volt and 10 kilo ohm from base connected to the ground, straightforward. Okay, now in between we have collected 0.01 microfarad capacitor and 8 ohm speaker. So 8 ohm is the resistance and then this is the capacitor and this is, so if I remove this capacitor and remove this speaker, then the collector is directly connected to sink and base after 10K it is directly connected to sink. So this transistor dual would be considered as in active state. Okay, so it would be conducting kind of signal, electrical signal. Okay, now if I connect this circuit, okay, if I think that there is a switch and I connect this circuit, so as per the characteristics of diode, so a charge would start accumulating in the diode, in the capacitor. Okay, so at the beginning when capacitor is discharged, this would behave as a short circuit. Okay, so at the beginning there is no capacitor. That means it's a pure short circuit. If it is a pure short circuit, so there will be current flowing through it. Okay, and speaker is receiving the current. After some time, when capacitor is charged, okay, so after some time when capacitor is charged, it is behaving like an open circuit. Means its resistance is infinite. If it is open circuit, current cannot flow it. So these two transistors will become open, means they are not active. I mean there is no current through the speaker at all. So when capacitor, so there are two, can we see now? So I can add now in our scenario, if we see, okay, so when transistor is active and when at the beginning the current is flowing through the capacitor, it is storing the charge. So slowly it will kind of obstruct the current, and one time happen it will be open. So at the beginning it will kind of shunt it and current would flow through the speaker and there will be noise in the speaker. And okay, so after that, once capacitor is charged, then it is disconnected and there is no current. Okay, so current can flow through the PNP transistor, but it is not in active state because it is kind of dangling and there is no current. Okay, now there is another scenario. Okay, so this would be considered as third scenario. Okay, so it is marked as green at the beginning, means it is passing the current, and when in open state it is marked as red, means capacitor is fully charged. When capacitor is fully charged, okay, this is 10K resistance and there is, okay, so this is a diode, okay, so when capacitor is fully charged, it is seeing this as a path to discharge. Capacitor is charged from this path. This is the voltage source. If this is the voltage source, current is flowing from here and capacitor is charged. When capacitor is charged, okay, then here 330 kilo ohm resistance is there and voltage source, so it cannot discharge through this path, but it is getting another path to discharge. Okay, and capacitor after some time, capacitor is discharged. If capacitor is discharged, okay, so if capacitor is discharged, okay, it will again behave like a short circuit. Okay, the moment its resistance, so discharge means its resistance is lowering, and one moment will come that it will be short circuit. The moment current starts flowing through it, then there will be again noise in the speaker. Okay, and once it is charged, when it is being charged, Okay, so once it is being charged, after some time it will become fully charged and it will make it as open circuit, and then again there is no current. So it would behave like a kind of current going up and there is no current, current going up and there is no current. So we can kind of think like, okay, so probably we can draw it here. Okay, so beginning there is a flow of current and then suddenly current comes to zero. It will remain as zero till capacitor is discharging. Then current will come up again and current will remain, okay, till capacitor is charging. Then current will go down and capacitor is discharging, and then current will come up. And so this is a kind of vague idea that this can be the kind of current coming, means voltage is developing there and not developing there. It can be means it is on and off, I can say. It can be exponential, this curve what we are saying. Okay, so if a speaker is receiving current and not receiving current, it will do tick 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 kind of that. So now in our actual lab, what we have done in the actual lab, so the capacitor value, okay, so I can kind of close it. Okay, probably it should go away. Okay, so now what is the actual scenario what we have taken in our lab session? Okay, so probably we can add a slide called lab, and then what we have done in the lab, that we'll see. Okay, so now we understood that capacitor is behaving like a variable resistance. Okay, so in lab session, what we'll see, so I have taken it as kind of 1 microfarad. Okay, it won't be that much high speed tick tick tick. Okay, otherwise 1 microfarad, and instead of 3 volt, I couldn't arrange it. So I got 2.7 volt, 2.6 volt, 2.59 volt rather, in actual sense. Okay, so this is what we'll see in the lab. Okay, so this is lab. Okay. Okay, so now what we are going to do now? Okay, so now we have a kind of a lab session, and in lab session, as discussed, we have kind of okay, so now we have taken 1 microfarad capacitor. So tick will not be that fast because charge and discharge will take time, and 2.59, but it works. Okay, and 8 ohm speaker is there, so that I could not arrange, so I have taken kind of one old mobile speaker, so that I have used. Otherwise it is 10K and it is 330K BC 547 NPN transistor and BC 557 as PNP transistor, so that we have taken. So now we'll see the variable resistance that is developed through the capacitor, and one is charging circuit. So charge comes through the battery source to the capacitor, and through this loop it would discharge. Okay, it will discharge to a level that it will connect again and it will charge. Okay, so once it connects while charging, so speaker would kind of, it will start speaking. So that is the idea. Okay, so that we'll see in the lab. Okay, so we have connected the circuit. So the voltage source is around 2.6 volt, and okay, so I think I'll show through this. Okay, so this is one resistor 330 kilo ohm, and there is one resistor here inside, and that is 10 kilo ohm, and the capacitor here we have taken 1 microfarad. So based upon the time constant, so that much it will take. So if I disconnect anything, so sound would go off. So if I disconnect the battery, okay, now if I connect the battery again, okay, so this is kind of oscillation we are able to generate. So capacitor is kind of charging and it is discharging in some time. So probably we can add a bigger capacitor to have the sound not so frequent, or lesser than this capacitor for the sound to be kind of more frequency. So that is the concept. So here what we see, this transistor is NPN and here this is PNP. So circuit is kind of connected the way it is shown in the diagram. Okay, so quickly I'll test the speaker. Okay, so if I disconnect anything, if I take out the capacitor, the sound would go away. Okay, so I'll connect the capacitor again. Okay, so quickly we will calculate the kind of its voltage. Okay, so I'll disconnect it. Okay, so okay, so it is around 2.6, 2.59 volt.